Okay, so this was the warm-up. This is the start of factoring. Really this, I mean, we're going to take factoring, break it down basically over 4 days, right? So this was the first two kinds, which was difference two squares and the perfect square trinomials. Okay, so number one, and greatest common factor. So number one, the first thing you want to do is look and see if you can factor anything out. There's like a 16, a 40, and a 25, not all divisible by the same thing, so I'm not going to go that route. The next thing I would look at is if there's 3 of them as of now, we really only had the perfect square trinomial to do. Obviously, by the time we get to the end, they're all going to get blended in together. But the hint for the perfect square trinomial is that this and this are both perfect squares. And then remember our test is square root the first term, so it'd be 4. Square root the last term, so it'd be 5. Multiply that and then double it. And if it equals the middle term, then I know I have a perfect square trinomial, which is the case. To factor it, we square root the first term, which would be 4x. We square root the last term, which would be 5. Take the sign from the middle, which is minus, put it in the parentheses, and square it. Questions on that one?
No.
Okay. 2. Difference of 2 squares, right? The difference obviously is because it's a minus in between 2 perfect squares, 121 and 9. They're both perfect squares. So I'm going to factor it. I'm going to square root the first term, which would be 11x. I'm going to square root the last term, which would be a 3y squared. One gets a plus and one gets a minus. And to make our life a little bit easier, we'll go in that order so everybody gets the same answers. Still good? That one you actually could have taken, oh no, never mind. I was thinking you could take out a 3. That is not correct. Ignore me. All right, number 3. Now I've got where it looks like it's perfect square. I mean, they're not perfect squares, but there is a common factor, right? All 3 of these are divisible by what?
5.
5, and also now look at the variables. All 3 of them are?
5x squared.
Good, I could take out an x squared. So I'm gonna divide each of these by 5x squared. Open up my parentheses. 45 divided by 5 is 9. X squared and x squared would cancel. Minus 20 divided by 5 is 4. X squared divided by x, x to the 4th divided by x squared is x squared. And 15 divided by 5 is 3. And x to the 3rd divided by x to the 2nd is x. So this is factored completely. Everybody good so far? All right, so again, we're going to continue with the factoring today, but before we get to that, let's go over the homework from last night. Remember, the odds can be found on Calc Chat, okay? So I'm going to mostly highlight the evens. I'll read the evens out loud because I know some of you are in Notability checking work. So I'll read them out loud. And then if I need to redo them, just let me know. So 6 is 3z times, parentheses, z squared minus 2z plus 3. 8 is x plus 3 times x minus 1.
How did you get 7?
So this 7, when you take out the greatest common factor, it's x minus 5. So that comes out first, and then what's left over is 3x plus 8. So that gets grouped together second.
Can you go over 16?
16. 10 is x plus 8, x minus 8. 12 is 2y plus 7, 2y minus 7. 14, first you take out the 9, then you get 3 plus 2z and 3 minus 2z. 16, take out a negative z, z plus 10. So that one can be simplified. 18, x minus 2y, x plus 2y, and x squared plus 4y squared. So that could be factored twice again. Then 20, factoring a perfect square trinomial. 2t plus 1 squared. 22, 6y plus 7 squared. 24, 3u plus 4v squared. Questions overall?
Can you go to the first page, please?
Sure.
Yeah.
Sure. So this one's, I think it's a tricky one. 25 minus z, write the right letter, z plus 5 squared. So this is the difference of two squares, right? But when I square root them, square root of 25 would be 5 and 5. And then this is a perfect square. So the square root of it is actually z plus 5. And this would be z plus 5. One gets a plus and one gets a minus. So from the first set of parentheses, I end up with 5 plus z plus 5, which becomes z plus 10. And the second set of parentheses, that minus goes to both. So it's 5 minus z minus 5. And then the 5 and the negative 5 cancel out, and it's just negative z. They just put that on the front. So you can put it either way.
Okay, thank you.
You're welcome. That one was tricky.
Can you go over 18?
Sure. 18 x to the 4th minus 16y to the 4th. Okay, so again, difference of two squares, right? So I'm going to set up my two parentheses. Square root x to the 4th, it's x squared and x squared. Square root 16y to the 4th, and it's 4y to the 2nd and 4y to the 2nd. One gets a plus, one gets a minus. Now the first parentheses is done, but the second one, oh, this should be squared. The second one is, again, the difference of two squares. So I rewrite the first one, but the second I'm going to split into two. Square root x squared, and I get x and x. Square root 4y squared, and I get 2y and 2y. One gets a plus, one gets a minus.
Could you do 14, please?
Mm-hmm. Okay, 14. Difference of two squares again, right? Oops. Except this time you can factor something out. So I can take out a 9, and I get 9 minus 4z squared. Now it's the difference of two squares. 3 and 3, 2z and 2z. One gets a plus and one gets a minus. If you had factored from the get-go without taking out the greatest common factor, you should have got 9 plus 6z, 9 minus 6z. And then the greatest common factor can come out of both of these. A 3 comes out of here. Oops. And a 3 comes out of the second one. These can get multiplied together, and you'd get the same answer. You want to make a habit, though, of always checking for the greatest common factor first, because you're going to see when we get to the end and we're putting all of this stuff together, that's the first thing you want to check for, is can you take something out from the very beginning?
For number 16, how did you get a negative z?
So when I factor the 25, it's 25 and 25, right? When I factor z plus 5 squared, one's here, one's here. One gets a plus and one gets a minus, which means that minus goes to both. And then I get it here. You're welcome. Everybody else okay? You ready for more factoring? I mean, what could be better? At least the background's pretty. This one makes me happy. Chapter P, section 4 is and we're gonna do part 2 is factoring perfect cubes and grouping. So we're gonna do 2 more methods today. We'll do 2 more tomorrow, then we'll blend it all together, okay? So we start with perfect cubes. And perfect cubes mean that both the first term and the second term have to be perfect cubes, meaning something raised to the 3rd power.
Miss Chris Weiser?
Yep.
Are you screen sharing? Because I can't see it.
Can anybody else see it? Yeah? All right, let me stop.
Okay, thank you.
You're welcome. So both of the terms here have to be perfect cubes. You can this time have a sum or a difference. So the difference between this and obviously difference of two squares is that's a difference of two squares. It has to be a minus. They both have to be perfect squares. Now these have to be perfect cubes, but it could be the sum or the difference. So you can have a plus or a minus. And then the pattern is this. You're going to take each of those and you're going to cube root them. So if it was 8, my cube root is 2. If it's x to the third, my cube root is x. Okay, you're going to cube root those. And then the pattern is as follows. It's the first cubed, once it's cube rooted, plus the second one, times first squared goes first, second squared goes last, product goes in the middle. And then we'll talk about signs in a minute. Same thing for here. First cube root, second cube root, square the first one, it goes first. Square the last one, it goes last. Put the product in the middle. And then the terms, so if it's plus, then it's plus, minus, plus. If it's minus, plus, plus. So actually one of my pre-calc kids just asked me, is this soap? Okay, because somebody taught her that, which it makes sense perfectly. The first term, this sign is always the same as my initial term, so it gets the S. That's same. The second sign is always the opposite of my initial term, so think O. And the last one is always positive, so there's the AP in soap, okay? So soap, S is same, then opposite, then always positive. The last one's always positive. All right, let's work through an example on this one and then we'll get to the next one. So the first thing you have to do is identify that these are both perfect cubes, okay? The variable has to have an exponent that's a factor of 3, because that's how you know it's a cube. It could be to the third, it could be to the sixth. This one is, so my first term is x. Cube root 125, and my answer is 5. If I didn't know it, I would get 5 and 25, which is 5 and 5. That's 3 5s, which is exactly 1 5. Then I do the first term squared, the second term squared, and the product in the middle, which would be 5x. And the signs go same, opposite, positive. So same as the original is minus, opposite would be plus, positive is the last one, and there's my factored perfect cube. I think this is the most complicated, well, not, for now, it's the most complicated one. Because it's like a memorization pattern. Corona perk, you'll probably have a reference sheet, so you could write this on a piece of paper. Not something that happens normally during the school year. There's one positive. All right, let's work examples, okay? So I'll do some with you, and then I'll let you work on some by yourself. Where's my hot pink? I need pink for this slide. All right, first one. Again, they have to be perfect cubes, so I'm looking at x to the third and 27, and I'm saying, yes, I know those are both perfect cubes. So I'm going to cube root x to the third, and I get x. I'm going to cube root 27, and I get 3. Put those in parentheses. Square the first one, so it's x squared. Square the last one, that's 9. Multiply them together, that's 3x, and that's the middle term. So if I want to cube root this and cube root this up here to remind me what it is, go for it. Now, same, which means this is minus. Opposite, which means this is plus. Always positive, which means that's plus. And there's my factored form.
Why is the last term 9?
Because it's the last one squared. So here goes first one squared, here goes last one squared, here goes their product.
Okay.
And when in doubt, FOIL it and double check. If I FOIL this out, I should get back to my original question, right? So if I check this, and I did first, it'd be x to the third. Then here, 3x squared. Then here, 9x. Then here. Then here. Then here. Simplify. This would cancel. This would cancel. Minus 27. So every single factoring question can be checked. You just need the time to do it. All right, let's look at, I'll rotate this all around. Y to the third plus 8. So the cube root of y to the third is y. The cube root of 8 is 2. So it's the first and the second. First one squared, last one squared. Product of the 2 in the middle. Same sign, so it's a plus. Opposite sign, so it's a minus. Same, always positive, so it's a plus. All right, 3, 64, x to the third minus 1. So cube root here, oops, is 4x this time. Cube root of 1 is 1. So it's the first two together. Square 4x and I get 16x squared. Square 1, I get 1. Multiply the 4x and the 1 together. And then do your signs. Same, opposite, positive. Questions on that one? All right, now look at 4. Is 3 a perfect cube? It's not. What can you do here? Happy birthday! Are both 3 and 192 divisible by 3? Yes, right? We have to take out the 3 first, and I'd get x to the third, 192 divided by 3 is 64. Now they're both perfect cubes. So cube root x to the third and I get x. Cube root 64 and I get 4. So the 3 is going to stay on the front. But then I do x with 4. X squared. 4 squared. Product in the middle. And the signs go same, opposite, positive.
I still don't understand where you're getting the middle number.
So the first one is the square of this term, right? The last one is the square of this term. The middle term is the product of these two. So multiply them together.
Okay.
How did you get 4?
It's the cube root of 64. So if you don't know it, then you got to break down 64, right? This would be 8 and 8, 2 and 4, 2 and 2, 2 and 4, 2 and 2. There's 3 2s, so one's going to go outside. Another 3 2s, so I'd bring both of them outside, and I get the cube root of 64 is 4. I would maybe even come up with a couple, like maybe a little cheat sheet for yourself, like 2 to the third, 3 to the third, 4 to the third, 5 to the third, 6, like maybe a little bit of cheat sheet like that, because you're going to see a lot of the same numbers over and over again. Questions? Everybody okay on cubes? Okay, you try these. All right, so first one, cube root of 27x to the third is 3x. Cube root of 1 is 1. You should have gotten 3x plus 1. Square the 3x and you get 9x squared. Minus 3x plus 1. Then 6, cube root 64y to the third and you get 4y. Cube root 125 and you get 5. So you get 4y minus 5. Square 4y at 16y squared. The product of these two would be 20y. And then 25 is 5 squared at the end. Now 7 gets a little trickier because the first one is an actual binomial. So the cube root of this is x plus 2. The cube root of this is y. So I do the first two, which is x plus 2 and y. Square the first one. So I'm going to have to do x plus 2 squared. I'm going to go back to that. Square the last one, y squared. Multiply these two together and I'd get y times x plus 2. Now my signs, same, opposite, positive. Now I've got some work to do because I have to expand this and FOIL this. So x plus 2 times x plus 2 becomes x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. So the first one's going to stay the same. Then I get x squared plus 4x plus 4. Distribute the y here. And I get xy plus 2y plus y squared. Now look and see if you can combine any like terms, and you can't, so it stays this way. It's ugly, but it's right. All right, last type of factoring for today is factoring by grouping. This happens when there's 4 terms. So if there's 4 terms, then you're going to group the terms in pairs, 2 together, 2 together. You're going to factor out the greatest common factor from each of those sets of parentheses until what's inside the parentheses matches. Then that becomes your greatest factor. You're going to take that out and group together the remaining terms. So for this example, there's 1, 2, 3, 4 terms, right? So 4 terms. I'm going to group these 2 together. I'm going to group these 2 together. From the first set of parentheses, I'm going to take out the greatest common factor, which is x squared, and I get x minus 1. From the second set of parentheses, I'm going to take out the common factor, which is a positive 2. And I get x minus 1. So now what happens is my greatest common factor is a binomial. I take that out and I group together what's left. And there's the factored form. So again, this happens with 4 terms. Okay, let's look at some examples. Directions still just say factor the polynomial, so you've got to know, shoot, there's 4 terms there. That means I have to factor by grouping. So I'm going to group these together. From the first set of parentheses, what number goes into both 8 and 6? 2. What goes into both 8 to the 5th and 8 to the 2nd? I'm sorry, x to the 5th and x to the 2nd.
Squared.
Good, x squared.
X squared.
So I divide this by 2x squared and this by 2x squared. And I get 4x to the 3rd minus 3. Then I go to the next set of parentheses. What can I take out of both 12 and 9?
3.
3. And then I divide each of these by 3 because the second one doesn't have a variable, so that's it. X to the 3rd minus 3. Oops, 4x to the 3rd minus 3. Now what's inside the parentheses is the same. So I take that out. And I group together what's left. You always want to see if it can be factored further, right? There's a cube on that first one, but 4 is not a cube, perfect cube, and neither is 3. Okay, it's not the difference of 2 squares, so just make sure you can't keep factoring, but you can on this one. All right, number 9, again, 4 terms, group them. Notice I'm keeping the negative with that 5. I don't want to put it out front because that changes the negative 5 too. For first set of parentheses, I can take out a what?
X squared.
Good. And then I get x plus 1. Second set of parentheses, I can take out a what?
A negative 5.
Good. If you take out a positive 5, the signs aren't going to change, which you need them to. So I'm going to take out a negative 5. Now what's inside the parentheses matches. X plus 1. Group together, what's left? X squared minus 5. Now if that 5 was a perfect square, I'd factor that because it would be the difference of 2 squares. But it's not, so my answer stays this way. We still alive, people. You're still awake. I know it's 2:20. We're hanging in there. It's a Tuesday. Full of fun for factoring. Yeah, okay. Questions before I move on? All right, last set of examples. Again, factor the polynomial. This time I'll let you try them first. So you try first. All right, so the first one, I'm going to group. What can I take off of the x to the third plus 5x squared?
X squared.
X squared, good. And I get x plus 5. What can I take off of the negative 5x and the negative 25?
Negative 5.
Good, negative 5, and I get x plus 5. Then, is this the same example we just did? X plus 5 and x squared minus 5. It is, right? I totally duplicated that. All right, so I put it right on there, but it says skip that last group, the 49 through 60. The rest of them you need to make sure you submit.